We talked about having two lines cut by a transversal, didn't we? Those lines weren't necessarily parallel to each other, were they? All right, but you did have two lines, and you had this transversal. Now notice, the transversal intersects both of those lines, doesn't it? In order to be a transversal, it's got to hit both of those lines. So this would be our transversal. We'll call this transversal T. And we'll call this line L and line M. And we had a bunch of angles, didn't we? 1, 2, 3, 4, 5, 6, 7, 8. And we found a relationship, or a name of the relationships between these angles right here. So let's see, 1 and 5. Tell me what 1 and 5 are to each other. Corresponding angles, very good. What about 4 and 6? What are they? Good, alternate interior. What about 3 and 6? 3 and 6. Consecutive interior, right. They're both interior angles. They're consecutive interior. What about 2 and 8? Alternate exterior, good. What if I ask for 1 and 2? Yeah, I'd say a linear pair, okay, because they're two angles that form a straight line. You could say they're supplementary if you wanted. Sure, that wouldn't be wrong. They're also, what else? What else is 1 and 2? What is it? Adjacent, right, good. Okay, all right, so you know a bunch of words now, don't you? And that's what half of geometry is, learning the words. I talked to Joanna. Do you know Joanna Hong? She's a really bright girl, especially in math, okay? And I wouldn't say she struggled, because I think if I added up all the problems she got wrong between all her quizzes and tests, she might have gotten maybe 3 problems wrong the whole entire year out of all the quizzes and all the tests we took. But she did say she had to study a little extra for geometry because there's so much vocabulary. I mean, she's just learning English for the first time, right? Well, not for the first time, but, you know, she's fairly new to English, and it's not her first language. But in geometry, just think of how much more difficult geometry would be if it was English was your second language, because it's pretty tough learning all these brand new words that you never learned when you took English class, So so be lucky at least you speak English, because it is a little tougher to do geometry if it's your second language. Okay, so anyway, here we go. Let's do this. Now those two lines, let me pop back up here. Remember what I said at the beginning? Were these two lines necessarily parallel to each other? No, but guess what we're going to do today? We are going to make them parallel to each other, okay? And we have a lot of stuff that we know. Now, the only thing we knew yesterday about those lines, we didn't know anything about any angles being equal to each other or angles being supplementary, except if it was a linear pair. We didn't know any of that stuff. But today, we're going to learn a few things about the relationship between these angles. And but these two lines, watch, if I put a little arrow right here and a little arrow right there, they're not on the ends. That looked pretty ugly. Let's try this again. It's a little better. Okay, what is true about these two lines right here just by how I drew this? They're parallel. What says that they're parallel? The arrows. Okay, it's not just because it looks like it, right? So look, are those parallel? Well, you can't say no. What would your best answer be here? You can't tell. Very good. You can't tell. They look like it, right? But just because it looks like it, you can't tell, because nothing's given to you. They don't tell you anything about these two lines right there. They could do this. There's a couple ways they could do this. Watch. They could say that line L is parallel to line M. So if they told you this at the beginning of it, then sure, they're parallel to each other. Okay? What if they didn't tell you that, though? What if they just drew a little picture? If they do this and this, then they are parallel to each other, because those little things are drawn. If those are not drawn, then you don't know. You just can't tell. They might be parallel, but they might not be, right? Everybody agree with that? Okay, so now they are parallel to each other. Now we're going to draw something else. What do you think we're going to draw? Transversal, good. So let's draw a transversal about like that. All right? And let's number some angles again. Yes, Alex? The title of this is called Angles and Parallel Lines. Angles and Parallel Lines. So let's number just like we did before. But now we know the names of the relationships between these angles, but now we're going to actually learn something about the measure of the angles, okay, the value of the angles, okay, how many degrees and all that kind of stuff are. Let's just go in order what they do. They go corresponding, okay? This is your first thing. This thing right here is called a postulate. Postulate. It sounds fancy, doesn't it? A postulate is basically just a rule, R-U-L-E. Okay, it's like a rule for something. But a postulate, it's different. We're going to learn a couple of things called theorems in a second, in a few minutes. Theorems, but a postulate's a little bit different than a theorem. A postulate is just something that's accepted as fact. All right, we don't have to prove it. Somebody just tells us it's true, and we say, okay, well that's a postulate. It's true. So we can't really prove it. All right. These other things, thank you. These other things called theorems, we can prove. All right, but postulates are just accepted fact. Okay, without proof. They just tell us, and we believe it. All right. Does that make sense? So that's a postulate. So our first postulate is this. First. Oh, you're driving? Okay, there's a pile of tests up there. Go ahead and put it in there. Let's pause this. Okay, so what were we saying? Postulates, right? Postulates and theorems. So we accept this as proven fact. Now, remember the corresponding angles? Which ones are our corresponding angles here? Let's say 1 and what else? 1 and 5, right? They're corresponding angles. 2 and 6, 3n, 4n. Got it. Okay. Now, there's this postulate says, okay, that anytime that you have, it always starts off like this. If you have two parallel lines, do we have two parallel lines? Yes. Cut by a transversal. Are those two parallel lines cut by a transversal? Yes. So each one of these things starts off like this. If two parallel lines are cut by a transversal, I'm just going to shorthand it a little bit, okay? But every one of these starts off that way. If you have two parallel lines, not just any two lines in the world, two parallel lines cut by transversal, then this stuff is true. All right? So our first postulate says this, is that the corresponding, I'll just shorten it, the corresponding angles, let's just make a guess. Look at angle 1 and look at angle 5. What do they look like? Do they look like, yeah, this is obtuse and this is obtuse, isn't it? Now, it doesn't mean that every obtuse angle is equal to each other, okay? But they sure look like they're equal. If I had a protractor, if I had like me, I need to get an online protractor because I talk about this every once in a while. But anyway, not today. If I stuck a protractor right here and measured that angle and measured the angle 5, angle 1 and 5, they would be exactly the same. All right, so 1 and 5 are equal to each other. So what must be true about corresponding angles if you have two parallel lines cut by a transversal? The corresponding angles must be what? Right, the corresponding angles. Actually, I'm not going to put the word R. I'm just going to put the equal sign right there. So this is what our first postulate says. And again, a postulate is just a rule. It's an accepted fact. Okay, we just accept it as fact. We don't have to prove it. They tell us that the corresponding angles are equal to each other. Now, if I go way up here, all right, there we go. If I go up here, 1 and 5 are corresponding, aren't they? Are 1 and 5 equal to each other? No, they're not. Why not? Because these lines are not parallel. That's right. Okay, so I cannot say that 1 and 5 are equal to each other because I don't know that those lines are parallel. Make sense? All right, so you can only say that corresponding angles are equal to each other if the two lines are parallel to each other. Make sense? So we can make a little list here, can't we, of corresponding angles. So let's list so far the things that we know that are equal. All right, so angle 1 equals, because of corresponding angles, angle 1 equals what? Angle 5. Let's keep going. Angle 2 must equal what? Angle 6. What else? Angle 3 has got to equal angle 7. And angle 4 must equal angle 8. Okay, and watch this. Now this is very important. Why? Why are those equal to each other? Because what did we just say? Because you're right, the postulate says they are. That's right. But what are these? Why? Because, I'll put because what? What's our postulate say? Corresponding angles are what? Are equal. Now, through the book, they actually name these postulates. They'll number them, all right? And we have things called theorems, which we're going to do just in a minute here. They number them. I don't care about how they number them. You know why? Because this book might do this postulate in chapter 3, and so they call this postulate 3-1 or 3.1, right? 3.1. But what if another book does this postulate in chapter 2? What do you think they're going to call it? 2.1 or whatever, okay? So it just depends on the author of the book. There's no like one book that says this is called postulate number whatever. All right, so I never memorize these by the numbers of the postulates. I know that there are geometry teachers out there that do that, but it's just specific to that particular author of that book. So you don't memorize the number of the postulate, memorize what it says. Okay, so what does this postulate say? It says that corresponding angles are what? Equal. Okay, if what's true though? If the lines are, if two lines are parallel and you have a transversal, then the corresponding angles are going to be equal. Does that make sense? All right, that's pretty important. I know exactly why I'm saying this stuff right now because we're going to do a little bit later, and you probably don't have a clue. But we'll deal with that when we get there. But the reasoning why, answering the question why, is going to be very, very important, especially in another chapter. Okay, so keep that in mind. So why are those angles equal? Because corresponding angles are equal. Don't just say because they're corresponding angles. Okay, say, technically, if you want to be real particular about it, you would say, you wouldn't just say because corresponding angles are equal. You would say because if the two parallel lines are cut by a transversal, then what? The corresponding angles are equal. Okay, because I left a lot out, didn't I? All right, but I just did that just to shorthand it a little bit, just to make things a little easier. But remember what this says. This says if the lines are parallel, cut by transversal, then the corresponding angles are equal. We good with that? So let's mark them all. So 1 and 5 are equal. Let's take a look at this. What else is 1? Up here, just by looking at this, without knowing any numbers whatsoever, what else is equal to number 1 up here? 3 is not. Look at 1. Because 1's obtuse, 3 is acute. There's no way 1 and 3 are equal to each other. But 4, why? Give me a reason. Because they're vertical angles, and vertical angles are equal. Remember we talked about this the other day? Okay, and that's another. Now we haven't gotten to it yet. Okay, remember I said that was kind of free of charge and that kind of stuff. We haven't officially said that vertical angles are equal, but you do know. Okay, I kind of gave sneak preview the other day. So we know that 1 and 4 are equal. Now watch this. What else is equal? What else is equal to angle 5 down here? Angle 8. Give me a reason why. Because the vertical angles are equal. Don't just say because they're vertical angles. Say because vertical angles are equal. Okay? Everybody got that? All right. Now watch this. Watch. What do we know about, let's say, 2 and 6? They're equal. Why are 2 and 6 equal to each other? No, they're not alternate interior. What are they? They're corresponding angles. And we have a postulate, don't we, that says that corresponding angles are equal. So 2 and 6 are equal to each other because they're corresponding angles. Right? Right here. What else? 3 and 7. Now, why did I put 2 arcs around here? Yeah, because it's a different angle than angle 1. Exactly. 1 and 2 are not equal to each other, right? So look at all the angles that are equal to each other. 1 and 4, 5 and 8. Notice, what do they all have in common? What kind of angles are 1, 4, 5, and 8? They're all obtuse. Okay, so when you have a situation like this, when you have two parallel lines cut by transversal, every single obtuse angle is what? They're all equal to each other, aren't they? You see that? What about 2, 3, 6, and 7? They're all equal to each other, and they're all acute, aren't they? Okay, so all the acute angles are equal to each other, and all the what? Obtuse angles are equal to each other. This only occurs when what? If. There's a big if in front of all this stuff. I should put it up here, shouldn't I? If two parallel lines, all right, so if you have two parallel lines cut by a what? Transversal. I'll just shorthand that, period, and then comma, what? Then the corresponding angles are equal. All right, so there's a big if right there. So look at all that stuff, okay? So now you know all the angles that are equal, and you know all that kind of thing. But let's go through some of the names. This is because of corresponding angles. Now we have a theorem. Our next theorem, let's see which one they do next. Okay.
So we're doing theorems now, not postulates?
Did you finish
Then
the statement?
it's already written right here. Then the corresponding angles are equal. I just skipped down to here. If the two parallel lines are cut by transversal, comma, then the corresponding angles are equal. A little sloppy. You could make it a little bit nicer on your notes, okay? So if two parallel lines are cut by transversal, then the corresponding angles are equal. That's a postulate. Do we have to prove that? No, we don't, okay? But there is a situation. Tell you what, just to save some space right here, I'm going to get rid of this stuff. You got it in your notes, right? Okay, but I'll get rid of up here. Let's look at some of the other, what are some of the other relationships? Like alternate interior angles. Let's pick that one. Okay, alternate interior angles. So 3 and 6. Now look at it. 3 and 6 are alternate interior angles, and they're also what to each other? They're equal to each other, aren't they? And so what are your other pair of alternate interior angles? 4 and 5. So what do you think might be true? If two parallel lines are cut by a transversal, then what? That's right. The alternate interior angles are also what? Equal to each other. Yeah, it does make sense, doesn't it? Yeah, exactly. Because if you put, well, they don't make a straight line. 3 and 6 won't make a straight line. Okay. 3 and 5 might. Okay. Well, and we'll get to that. Okay. That's good. You're thinking, though. That's good. So the alternate interior angles are what? Equal. Or actually the book says, they put a little squiggle there. What's that little squiggle mean? Congruent. Same thing. Okay. As far as I'm concerned, it's the same thing. Some teachers would get really upset if they heard me say that, but that's okay. All right, so the alternate interior angles are congruent. Let's list the alternate interior angles and let's write them congruent to each other. So we said what? Angle 3 must equal now what? Angle 6. And angle 4 must equal angle 5. Everybody see that? And what's your reasoning? Why does angle 3 equal angle 6? Because alternate interior angles are what? Equal. Now this is not a postulate. This is actually a theorem. Okay? A theorem you can actually prove. All right? A postulate is just something that's already accepted as fact. We kind of came up with this theorem, didn't we? Because we said that 1 and 5 are equal, and the only reason that you knew 1 and 5 were equal is because of that postulate. That's really the only way that you could have figured it out. But we did say 1 and 4 were equal because of vertical angles, right? And then we said 1, 4, 5, and 8. So we needed to know two things. We needed to know, first of all, the corresponding angles were equal and the vertical angles were equal. And then you can get 1, 4, 5, and 8 equal. We did the same thing with 2, 3, 6, and 7. All right? But then what did we do? We marked them all, didn't we? And so we looked at it and we said, wait a minute, 3 and 6, it shows that they're equal to each other. That must mean what? Alternate interior angles must be equal to each other. We kind of came up with that on our own. We kind of proved it, all right, that the alternate interior angles are equal to each other. Now, we had to know something beforehand, didn't we? We had to know that the corresponding angles were equal, and we had to know that vertical angles are equal. But we figured that out, all right, and then we looked at it and we said, hey, guess what? I can now say that 3 and 6 are equal. 3 and 6 are alternate interior angles, so they must be equal to each other. Does that make sense? So we kind of proved it, and that's what you do with theorems. Okay, on theorems, you actually can prove it. You can actually come up with a theorem on your own. A postulate, you just kind of have to be told that, all right? But a theorem, you kind of come up with it on your own, and you prove it yourself. So that's the difference between a theorem and a postulate. They kind of look the same, but we would have never been able to tell that alternate interior angles were equal unless we already knew that the corresponding angles were equal. Is that making any sense at all? Sounds like I'm talking in circles, but I think it makes sense. To me, anyway. All right, we good with that? Alternate interior angles? Okay, what about alternate exterior angles? Let's take a look at alternate exterior angles. Let's take a look. Look at angle 1. That's an exterior angle, isn't it? What's the alternate exterior angle with angle 1? Angle 8. Now look, what's true about angle 1 and angle 8? They're equal to each other, aren't they? All right, give me another pair of alternate exterior angles. 2 and 7. Good. 2 and 7 are equal to each other as well, aren't they? And they're alternate exterior angles. So what do you think now I can say? Here's another theorem. What do you think now I can say about alternate exterior angles? That they're congruent to each other, right? So they are congruent or equal, whatever you want to say.
Alternate interior angles are congruent too, right?
Yes.
Okay.
That's what we did just before this one. So the alternate interior are equal to each other. So 3 and 6 are equal, 4 and 5 are equal. And also the alternate exterior angles are equal to each other as well. So that means 1 and 8 are equal, right? So angle 1 equals angle 8. And what's my other one? Angle 2 and angle 7. So they're equal to each other as well. And we kind of came up with that on our own, didn't we? Right? We marked them all out, and we looked at them, and we're like, hey, wait a minute. Look, 1 and 8 are the same, and they're alternate exterior angles. So guess what? alternate exterior angles must be equal to each other. Does that make sense? All right.
If they're congruent,
Well, congruent equals same thing.
it's the same thing.
Means the same thing, yeah.
Oh.
If you wanted to be really picky, what they would do is say that angle 1 is congruent to angle 8. Let's say I knew what angle 1 was. Like angle 1 was equal to, I don't know, let's say 150 degrees. All right, we would say the measure of angle 1 is equal to 150 degrees. We wouldn't say it's congruent to a number, but we say two angles are congruent to each other. So figures, shapes are congruent to each other, but a lot of times they just use equal when they say the measure of something is equal to something else. All right, it's a subtle difference. It's really, to me, it's not that big, huge of a deal, but that's the difference between equal and congruent. All right. So when you talk about shapes, when you talk about a line segment is equal to another line segment, we would really say in geometry that they're congruent to each other. Okay, angles are congruent and all that kind of thing. All right, enough of that. What's another one of those relationships that we've discussed that we can look up here? What was another one? We did corresponding angles already up here.
Right, sorry. Never mind.
What about consecutive? Remember that one? Let's see about consecutive. I'll write the whole thing out. Consecutive interior angles. Now I'm not going to write what they are just yet. I'm not going to put equals just yet. Let's look at them and see, is there a relationship between the consecutive interior angles? First of all, are they equal to each other? Well, we've got to know which ones are the consecutive interior. Which ones are the consecutive interior? 4 and 6, right? Are they equal to each other? No, look, this is obtuse, which means it's bigger than 90. This is acute, which is less than 90. There's no way in the world that they're equal to each other. Would you agree?
They form a line.
But how do you know they form a line? Let's do a little, it's kind of like a little mini proof. Let's think about it a little bit. Because let's write this down. Watch this. Tell me something about angle 3 and 4. They add up to equal what? 180 degrees. Agree with that? Okay. Now watch this. Remember, we want to find some kind of relationship between 4 and 6, don't we? That's what we're getting at. All right. So I already got an angle 4 right there. What'd you say? 3 is equal to 6. That's right. So watch. Angle 3 equals angle 6. Guess what we can do here? Instead of saying 3 plus 4 is 180, what could we say? Right. Just do a little substitution. All right. That's the first time I've said that in here, but it's not going to be the last. We're going to do this quite a bit. I just substitute. Since 3 and 6 are exactly the same value, can't I just stick a 6 in for 3 instead? Do you see that? Because I don't know what 3 is equal to. Let's just make up a number. Let's say it's equal to 50 degrees, okay? So angle 3 is 50. Well, what's angle 6 going to be equal to? 50. So instead of saying 50 plus angle 4, I could say I could put an angle 6 in there, because what's angle 6? That's 50 as well, isn't it? So does it really matter which one I say? No, but now I can say that I can say that angle 6 plus angle 4 is equal to 180 degrees, can't I? What's true about two angles that add up to be 180 degrees? They're supplementary. Very good. Okay, you remember that word. So if these two angles they add up to be 180 degrees, 4 and 6, they're consecutive interior angles, aren't they? So what do I say about consecutive interior angles? Do I say that they're equal to each other? You say that they are what? Right, supplements to each other, or we just say that the angles are supplementary. All right, they're supplementary angles. So consecutive interior angles, they're not equal to each other, because if you look at it, there's no way in the world they're equal, right? That's a big old obtuse angle. This is a little acute angle. There's no way they're the same, but they are supplementary to each other. And do you see what we just did right there? This is basically a proof. Okay, we proved that this theorem right here, this is another theorem. Okay, and I don't care what you number them, all right, because, you know, books number them differently. But this theorem right here, we figured it out on our own, didn't we? That's kind of cool, isn't it? Kind of coming up with our own rules, right? They give us one basic rule about corresponding angles being equal, all right? And then from there, we started marking angles and stuff, and we kind of came up with some of our own rules, didn't we? All right? And these are theorems. These are all theorems. So consecutive interior angles are supplementary. So that means angle 4 and 6 add up to 180. So let's write this down. So angle 4, this is my little shortcut. Angle 4 is supplementary to angle 6. Notice I didn't put equals, I didn't put congruent, did I? I put SUPP for supplementary. What else could I put in here for supplementary? Because of consecutive interior angles. What? Angle what? 3 is supplementary to what? Angle 5. Good. Okay, so consecutive interior angles are supplementary. I don't think they have a consecutive exterior, but if you look at it, but look at 2 and 8. What must 2 and 8 be? They got to be supplementary as well, right? Would you agree? And what about 1 and 7? They're supplementary as well, okay? So when you have a situation like this, let's wrap it up. When you have a situation like this, two parallel lines cut by transversal, all the obtuse angles are what to each other? They're equal to each other, right? What about all the acute angles? They're equal to each other. What if I took an obtuse angle, any obtuse angle in this situation, and any acute angle in this situation? What would they be to each other? They would be supplementary, which means what? What do? They add up to be 180 degrees. Very good. All right, is that making any sense? All right, very, very good. Okay, here, we got a few minutes. Let's do a little example. I'm looking at the top of page 180. Let's just kind of draw that so you can kind of see what's going on here. Now look, the parallel lines don't always have to look like horizontal, like I drew them. I mean, they could be slanted like this, couldn't they? And, I don't know, let's go orange. Let's make it like that. Let's scooch it over a little bit. Alright, so here you go. Now watch what I do. Put a little arrow here and here. So what's true about those pinkish purplish lines? They're parallel to each other. And of course this orange one is what to it? It's transversal, okay? And let's put some stuff in here. I'm going to label them just like they do in the book. 1, 2, 8, 3. They kind of jump around a little bit, don't they? 7, 4, and then 6 and 5. Okay? And here's what they tell you. They tell you angle 4 is equal to 2x minus 17. And they tell you that angle 1 is equal to 85. And they say, find x. Find x. Alright, well let's mark this. Let's use a different color. Let's find angle 4. Angle 4 is right here. Okay, so I'll put one arc around angle 4. What about angle 1? Let's find angle 1. Now look at angle 4 and angle 1. Do I put one arc around them both? No, because this is obtuse and this is acute, correct? So, do we set these equal to each other? This is 85 degrees, isn't it? Because angle 1 is 85 degrees. This angle right here is 2x minus 17. We don't set them equal to each other because this is obtuse, this is acute. So what are they then? If they're not equal, they're supplementary. That's exactly right. So what am I going to do with this? I'm going to add them up. So 2x minus 17 plus what? 85. So I've added the two angles together. What do I set them equal to now? 180 degrees. Now you just do the math and solve for x. I'll let you do that on your own. X is 56. Because they're supplementary. Because this is acute, this is obtuse. Remember, any acute and obtuse angle in this situation are always supplementary to each other. Right? All the acutes are equal to each other. All the obtuses are equal to each other. Right? But one acute and one obtuse have to be supplementary. That's why we add them up and set them equal to 180 degrees. Alright, did you get that? 56? Okay, we good with that? Let's do another. Let's do this one. Angle 3. This time they tell you angle 3 is 4y plus 30. 4y plus 30. And angle 7 is equal to 7y plus 6. Alright, so let's mark them. Angle 3, we'll put 2 arcs here since that had 2 arcs. And angle 7, this one right here. Now this is acute. Which one's this? This is acute as well. What's the relationship between 3 and 7? Give me the name, the words that we used in the last lesson. What is it? Alternate interior angles. Exactly. And what do we know about alternate interior angles? They're congruent to each other. That's right. Okay, they're the same. They're equal. So angle 3 and angle 7 are both the same. So what am I going to do with these two things? Set them equal to each other. That's right. So watch. 7y plus 6 equals 4y plus 30. Let's do this in our head. Subtract a 4y. That'll give you 3y. Subtract a 6 will give you 24. Y is 8. And there you go. Because it said solve for y. Sorry, I should have told you that. Solve for y. And if you wanted to, you really could find what those angles are equal to then, couldn't you? Right? Plug them back in. So they could ask you a couple different things. They could sometimes just say solve for x, solve for y. Sometimes they may say find angle 3. And you got to just plug it in and figure out what it is. That wouldn't be hard, right? What would it be? 8 4s are 32 plus 30 is 62. So this would be 62. And you're like, wait a minute. That can't be 62 and that be 85. They're two separate problems though, right? This is the yellow one is part A, and then the green one is part B. They're two completely separate problems. They don't have any relationship with each other. Okay, enough of that. That seems pretty easy, doesn't it? Yeah. This is really important. This is one of those big-time lessons that you're going to use a lot throughout your geometry. It'll probably be close to as easy. So let's see what we got. Section 3-2. And we're going to do pages. Don't you hate when I say pages? 11 to 29. That's not too much. There you go. Alright, so that is your homework. Stay in your seats till the bell rings. Don't walk around. Don't go up to the door. We only got a couple minutes left, so you can talk if you want until the bell rings.